Hello students. So we already learned Z statistic for single sample mean testing. Now we will learn T statistic. So difference between Z and T statistics, there are two methods are there. So one is in Indian rule or Indian method where sample size is actually does matter. So if sample size is more than 30, then we will generally follow Z statistic, and if the sample size is less than 30, then we will generally follow T statistic. So these Indian rules. In other case, in other words, we can also say in T statistic, obviously sample standard deviation is known, but Z statistic, if sample standard deviation, population standard deviation should be known for Z statistic. Okay, so now in T, so it depends on the when we use T statistic, when you use Z statistic, it depends on the nature of the problem given. Okay, so if the sample mean and sample standard deviation both are given, so and the sample size is less than 30, so all the characteristics and all the properties are satisfied, then use T statistic, because sample size is better option, because we do not have the option to find out the population variance or population standard deviation. So it is not actually in general practically possible. So now this is the some points we need to remember to apply T statistic. The sample size should be less than 30. The sample standard deviation or variance is known, and the formula of T statistic T equal to x bar minus mu divided by s by root over of n minus 1. So remember, in Z statistic the formula is Z equal to x bar minus mu divided by sigma by root n, where sigma is the population standard deviation, and here we use s by root over of n minus 1. X bar minus 1, the numerator portion is same as Z statistic, only the denominator portion will be changed as s by root n minus 1, where s is the sample standard deviation. In case of Z, it is population standard deviation, and in case of Z we use root n, and here we use root over of n minus 1. Okay, so everything is written here. And n minus 1, this is in case of T and T distribution, there is a parameter degrees of freedom. Okay, so such as in case of normal distribution, the parameters are mean and standard deviation. In case of T distribution, the parameter is degrees of freedom, and actually degrees of freedom, it is denoted by sample size minus 1. That is, if the sample size is 30, then 30 minus 1, 29 is the degrees of freedom of this distribution. Now come to this example. A salesman is expected to affect an average sales of 3500 rupees 3500 per day. So this is expected. A salesman is expected to earn this much of money or this much of sales per day. Okay, observing the sales of a particular salesman for 6 days. So look at this, 6 days we are observing for 6 days. So obviously, how many sample size? Sample size is 6 days here. So n equal to 6. Now after observing these 6 days, we see that he gives the average sale of 3300. That is, this is the average days of 6 days average of selling 3300 rupees per day. Okay, but he is expecting 3500. Okay, but after observing 6 days, it is 3300 per day with a standard deviation 1016 point this. So sample is size is 6 days, and sample mean, that is average sale of 6 days, is this one, so it means it becomes the sample mean. And for 6 days standard deviation is 1016. So what is this? This is a sample standard deviation. So look at this, sample means sample standard deviation is given. So what I told, if sample standard deviation is given, then we should use T statistic. And the sample size, look at this, 6 days, so n equal to 6, so it is less than 30. So if it is less than 30, we will obviously use here T statistic. Okay, and we should record to find out the conclusion, it is whether the null hypothesis is acceptable or rejected. at 5%, 0.05 level of significance. 0.05 means 5% level of significance. And look at this, given that t 0.05 equal to 2.02 at 5 degrees of freedom. Okay, so now let's start the example. So here sample size is 6, I already told you. Now what is mean? Mu is the population mean. So what is population mean? Population mean is what he expects to earn. So 3500, it is the expected earn. That is, he expect that if I earn 3500, it will be better for me. But in practical, after watching 6 days, it is observed that 3300 is the earning. So this is the sample mean, and 3500, it should be considered as the population mean. So mu equal to 3500. So mu equal to 3500. No, so now what is the first step? First step is set the hypothesis. So H0 null hypothesis is mu equal to 3500. Okay. Alternative hypothesis, instead of not equal to sign, that is mu not equal to 3500, we use here less than. Why? Because look at this example. Using 0.05 level of significance, conclude whether his work is below standard. What is below standard? Below standard means the earning per day 3500 should be less than this. That is, earning will be less than 3500. Okay, so what is less than 3500 means mu obviously less than 3500. Okay, so below standard, it means if the earning is less than 3500, then we will say that it is below standard earning. So obviously, what will be our alternative hypothesis? So alternative will be it will be a one tail test, and we should consider here less than mu less than 3500. So it is also written here as a note. So now for step 2, test statistics. So I already told you why we should test here as a t static. We should choose t statistics because of the reason, because sample size is 6 less than 30, and also standard deviation, sample standard deviation is given. So we will apply this formula. So after putting the values, x bar is the sample mean, which is 3300 already given in the problem, and n is 6, that is number of days is 6. Sample size, what is s is the sample standard deviation, which is 1016.53. Put the values here. And what is mu is already we set the hypothesis mu equal to 3500. Put all the values here, and we will get minus 0.44. okay, at 5 degrees of freedom. So n minus 1 and say 5 degrees of freedom. In general, we do not look after this 5 degrees of freedom. It is not necessary. Whatever we have to check minus 0.44, whether it lies in the critical region or not. So now look at this. Our test is, it is left tail test. Less than sign means it is left tail test. That is, our critical region will be in the left side. Now come to this figure. Now we have to set the critical region here. So this is one tail test, not a two tail. So look at this, our critical region, and it is given that probability t is 0.5 equal to 2.02. What does it mean? It means that at 0.02 less than t less than infinity, it means, look at this picture, 0.02 and less than this one, that is this, and less than infinity, 2.02 to infinity, this value is given as 0.05. So already 0.05 is given, and 0.05 means it is 5% level of significance. Okay, so at 5% level of significance means already the value is given as 0.02. So we don't need to find out anything. But this is a left tail test. But what the value is given, 2.02 to infinity, that is the critical region is this. But we need, this is a right tail, we need this region. And t statistic, we know the t distribution, it is symmetrical, just like the normal distribution, it is symmetrical about y-axis. So if 2.02 to infinity is 0.05, obviously we can say minus 2.02 to minus infinity, it is also 0.05. So our critical region, we need to test it, it is a left tail test, so we need to test it in this direction or in this region, left sided region. Okay, so In case of it is a symmetry, by the symmetry of this curve, so this portion and this portion are equal, and this portion value is given, and by the symmetry we can say minus infinity to minus 2.02, this value is also same as 0.05, means 5% level of significance. The left sided value is minus 0.02. Okay, so now our critical region is this was is given. So now new critical region is minus infinity, that is minus infinity to minus 0.02 this, and it is also 0.05. So also 5% level of significance is obtained here, and the critical region changed to this one. Now just step 4 is check and conclude. Check and conclude means now you just need to check the t value, whatever we have. T value is minus 0.44. Is it lies inside this critical region or not? So minus 0.44 is some point in between minus 0.02 and 0, that is in between this region. Okay, look at this, minus 0.44 is in between this region, and our critical region is minus infinity to minus 0.02. So basically it is outside the critical region. If it is inside the critical region, we will reject the null hypothesis. If it is outside the critical region, so this is the confidence interval here now, so it lies into the confidence interval. So we say that the null hypothesis is accepted here. So null hypothesis accepted means his work is not below standard. Okay, so alternative hypothesis, look at this null hypothesis, mu equal to 3500. That is whatever he expect to earn, he will earn it. He actually will earn it. Okay, and mu less than 3500, it is alternative hypothesis. So it is below standard. So since we accept this null hypothesis and we will reject this one, H1 we will reject it. So since we are accepting this A0 mu equal to 3500, so then we can say that his work is not below standard. Okay, and this is all about it. Thank you for watching the video.